Framework for implementing quality management system for heavy construction equipment manufacturing industry. Abstract: the present quality management, QMS, system certification standard, or to be specific ISO 9001:2008 has been revised recently to ISO 9001:2015 version. The study examines the future conversion, primary causes, and its impacts on the various domains of business. The complete concept is explained with the help of case study in heavy construction equipment manufacturing industry. The revision will bring some benefits, viz. greater emphasis on involvement of top management in the process, address risks and opportunities in a structured manner, use simplified language and a common structure and terms for multiple management systems, address supply chain management more effectively, more user-friendly for service and knowledge-based organizations, less emphasis on documentation. The organizations aspire to implement and upgrade QMS as per ISO 9001:2015 will be benefited from the information given in this research paper. Also, the organizations which seeks the improvement by implementing QMS are also gets benefited by the information available in this report. The standard is being used by the organizations to demonstrate constantly the capability to supply products and services that satisfy customer and regulatory requirements. The previous version of the standard ISO 9001:2008 has been replaced by a new version of the standard, i.e., ISO 9001:2015, which is released in September 2015. The main areas of concern for the organizations are the steps to be taken to achieve the new version and become compliant with it. This research explains the framework for implementation of new revision of ISO in manufacturing industry. Also, explains the concept of ISO 9001:2015 in details, and also, helpful for industries seeking for upgraded quality management system and understand its impact on businesses to assess their performance. The interested organization in the quality management system can refer this report to enhance their understanding towards quality QMS. Keywords: quality management system, risk management, ISO 9001:2015, PDCA cycle, QMS principles, risk-based thinking, business performance. Introduction. ISO 9001 is a quality management standard that sets out requirements for organizations' quality management systems. In 1987, the first edition of ISO 9001 standard was formulated. It got the name ISO 9001:1987. Since then, 4 more editions have been released and named after the releasing year, 1994, 2000, 2008, and the latest version, which this project will concern, 2015. The 2015 version emphasizes stronger focus on the organization's stakeholders, its context, and has another high-level structure. This aims business organizations to be more efficient in their operations and improve the customer satisfaction. The approach to the research work is sequential. It includes the exploration of transition from ISO 9001:2008 to ISO 9001:2015 with focus on risk-based thinking and, to assess the impact of QMS on the effectiveness of performance of the organization. A case company. The case company is one of the most renowned construction equipment manufacturing industry in the world. It is an ISO 9001:2008 certified industry. It offers unique technology applies into road construction industry, viz. highways and airports, road widening and development projects. The organization has strong quality policy which reflects top management commitment towards quality of the products and delivery processes. 2. ISO 9001:2015 Quality Management System. A. Quality Management Principles. The quality management principle is explained in the Fig 1 as below. PDCA cycle remained unchanged in the revised standards. The cycle operates at both a process level and an overall level 2. It is shown in the Fig. Point 2. C. Risk-based thinking is at the core of ISO 9001:2015. Risk-based thinking has a very important place in ISO 9001:2015. To emphasize their dominance, The concept of risk occurs 48 times in ISO 9001:2015, compared with only 3 times in ISO 9001:2008. The addition of risk-based thinking has made the preventive measures of ISO 9001:2008 redundant. These preventive measures no longer appear in ISO 9001:2015. 1. De-analysis of ISO 9001:2008 vs ISO 9001:2015. The comparison of the ISO standards are noted in the Table 1 with parameters to be considered for QMS for ISO. Thus, the planning for the implementation of the ISO 2015 is made for the parameters revised in ISO. Table 1. ISO 9001:2008 vs ISO 9001:2015 11. The main causes of delay and cost overruns in such projects included, monthly payment difficulties, poor contractor management, delay in material procurement, poor technical performances, and escalation of material prices, etc. Hence, effective project planning, controlling and monitoring should be established to enhance project performance in order to minimize or avoid delay and cost overrun in gas pipeline laying projects. If implemented by employees within organization, it can be used for the performance evaluation of overall project and for the contractors working for the company. 13. The project schedule should reflect all the work associated with delivering the project on time. Without a full and complete schedule, the project manager will be unable to communicate the complete effort, in terms of cost and resources, necessary to deliver the project. 14. The industry experts and criteria for the AHP method were determined based upon 3 mostly used project management software are selected for this study. AHP method is applied with 5 different experts' opinion on the selection vectors are used to reach a subjective conclusion. 15. By implementing lean manufacturing principle, the unnecessary time for performing the fabrication operation were reduced by 120 hours, which leads to cycle time reduction of the above fabrication process and productivity increased by 7.6%. This reduction in the cycle time has significant impact on company's productivity. The value stream map developed gave a good idea of the process and the changes to be done. 16. Manufacturing execution system is a technological advancement which provides a competitive edge to manufacturing organization by promising 43.48% reduction in low efficiency downtime and 18.07% reduction in injection molding machine breakdown. 17. The criteria for selection any project based upon time elapsed, economic feasibility, issues related to get permissions for carrying out work. To get more understanding, surveys was conducted by floating a questionnaire to managers of different offices. The responses were then fed into model prepared on AHP software to derive the sequence of working on projects with above criteria. The inconsistency obtained after the analysis of 2.93% that is acceptable as maximum acceptable inconsistency not more than 10%. Moreover, the activities involved in different projects can be sequenced and a holistic project model can be made by clubbing activities of all available projects in a multi-project environment. 18. 3. Research design. A hypothesis model. To study the impact of implementation of QMS on business performance factors, a hypothesis model has to be considered as shown in the Fig. 3. The research model gives the impact of implementation of QMS on business performance, through improvement in mediator factors such as information quality, operating performance, design performance, supplier and customer relationships, product and service quality and business performance. These parameters as discussed as below. 1, 2. 4. Data analysis and results. A validity test. Content validity is the extent to which a measuring instrument provides adequate coverage of the topic under study. It determines the primarily judgmental and intuitive. It can also be determined by using a panel of persons who shall judge how well the measuring instrument meets the standards, but there is no numerical way to express it. Pilot survey has been conducted in order to understand the content validity for the questionnaire. B. Reliability analysis. A measuring instrument is reliable if it provides consistent results. It is measured by calculating reliability coefficient, Cronbach alpha, A, value for each factor. In our analysis it is calculated by using IBM SPSS statistical software. Cronbach alpha, A, values greater than 0.7 generally acceptable according to the literature. The Cronbach alpha value found to be lie in between 0.715, service quality, to 0.942, customer relationship. Table 3 show the Cronbach alpha values. See correlation analysis. All the correlations are found to be positive. Pearson's correlation coefficient is used to evaluate the relationship is noted in the Table 4. Table 4. Correlation analysis. Figure 4. Mean values implementation of QMS as catalyst for change. From the survey analysis, it is found that the major reason for implementing QMS as a catalyst to bring change are base point for quality improvement and to introduce new practices. Also, the value shows that QMS practices are the part of regular routine and also emphasize on the documents created are used in daily practices for improvements is plotted and is shown in Fig 4. Figure 5. Mean values use of QMS in daily practices. The survey also reflects reasons for implementation of QMS as to establish long-term relationship with customers and create discipline in organization is plotted and shown the Fig 5 and Fig 6. Also, customer pressure has very less impact on the reason for implementation. Figure 6. Mean values reasons for implementing QMS. Information quality. According to survey, QMS affected information quality a lot. The major factors under information quality are, info in record is complete and accurate, info is useful in daily practices 15 to 17 Fig 6 showed are the maintenance are posted on the shop floor, quality data is recorded and used to communicate the changes. The mean values for the improvement in information quality is shown in the Table 5. F. Design performance. Some respondent thinks it improved overall product design performance while some thinks it improved design durability. The most significant item that found in analysis is continuous improvement are made in product design are plotted for analysis and is shown in the Fig. 7. Figure 7. Mean values improvement in design performance. G. Operating performance. Fig 8 showed the significant impact that found are improved manufacturing quality and reduced cost of quality. While the values for mean lies in between 3.33 to 4. Figure 8. Mean values improvement in operating performance. H. Supplier relationship. Survey analysis emphasizes long-term relationship existing with supplier and suppliers are selected on the basis of quality of their product is plotted and noted the significance and is shown in the Fig 9. The mean value varies from 3.42 to 4. Figure 9. Mean values improvement in supplier relationship. I. Customer relationship. The major factor improved due to customer relationship is performance feedback data is collected from customers and plotted the relationship for the analysis and is shown in the Fig 10. Figure 10. Mean values improvement in customer relationship. J. Product quality. The mean values of measurement variables of product quality factor lie between 3.67 and 4.08 is obtained after the SPSS analysis in descriptive statistics and is shown the Fig. 11. Figure 11. Mean values improvement in product quality. K. Service quality. The value improvement in the service quality of items lie between 3.25 and 3.83 is shown in the Fig 12 with a positive response for most of the items. Figure 12. Mean values improvement in service quality. L. Business performance. Figure 13. Mean values improvement in business performance. Figure 13 showed the list's mean values of items of business performance factor. All the values are around 3.8, which means organizations agree with items of business performance factor. In summary, implemented thought the manufacturing processes. The assessment of impact of ISO 9001:2015 shows positive impact on case company. The analysis of the SPSS on the quality management system showed that QMS is implemented as a base point for improving quality processes in the organization and, it has been used in daily practices. Almost all respondent thinks there is positive relationship between implementation of QMS in organization and business performance. Information quality improved after implementation of standard. The implementation improved the design, operational performance of the organization, which in turn led to high product quality. Conclusion. The case company has successfully implemented new QMS ISO 9001:2015. Risk-based thinking is involved in each of the processes. Risk management plan is developed and implemented throughout the manufacturing processes. The assessment of impact of ISO 9001:2015 shows positive impact on case company. The result shows that QMS is implemented as a base point for improving quality processes in the organization and, it has been used in daily practices. Almost all respondent thinks there is positive relationship between implementation of QMS in organization and business performance. Information quality improved after implementation of standard. The implementation improved the design, operational performance of the organization, which in turn led to high product quality. There is significant information sharing between organization and the supplier or customer, which helps to develop more significant customer and supplier relationship. The good customer and supplier relationship led to provide good service to the end users. All proposed hypothesis is found to have positive significance. The correlation between operational performance and product quality is highly significant. However, there is not enough statistical significance found between the product quality and business performance. It is recommended for future researcher to collect more data or to test the relationship between product quality and business performance. Based on the research, it can be concluded that the implementation of QMS helps the case company on multiple aspects, but the major significance is found on information quality and product quality of the organization. Finally, the organization successfully changed the QMS to ISO 9001:2015 standard. Acknowledgement. We thankful to Production Engineering Department, VJTI, Mumbai 400,019 for financial support for this project work and giving us the opportunity to conduct the project in industrial environment.